Hello guys, welcome back. This is Rishang Verma and I have came again with a new video that is very actually interesting. Okay, that is basically you can say the root of the chapter, that is the equation of motion. Okay, so in this particular video we will try to understand equation of motion and we will derive the equation of motion with the method that is graphical method. Okay, you will learn something new in this particular video. Okay, the equation of motion can be derived easily with the help of some formulas, but in this particular video we are just learning something new. Okay, so with the help of graphical video we can easily understand and we can derive actually the equation of motion. Okay, so as you know, the equation of motion is valid for a uniform or you can say constant acceleration. Okay, so what are equation of motion? Okay, so what is equation of motion? Equation of motion, there are basically three types of equation. What are three types of equation? I will just explain you. The first equation is basically, first I will just make you familiar with the terminologies or the words. Okay, so what is actually equation of motion? Okay, so the motion of a body with uniform acceleration can be described with the help of equations called equations of motion. Basically these are the equations of motion by which we can explain motion in a good way, or with the help of these equation we used to solve the different types of numerical. We used to find the time, we used to find out the final velocity, acceleration, displacement, all other stuffs we'll see in our video. Okay, so the equation of motion are, okay, so first equation is your v is equal to u plus at. Okay, now the second equation is your s is equal to ut plus half at square, and your third equation is v square is equal to u square plus 2as. Okay, okay, so these are basically three equations. Okay, so first I will tell you what is u. Basically u is uniform velocity. What is u? U is uniform velocity. Here you can see this u is basically a uniform velocity. This is, oh sorry, not, it is not a uniform velocity, it is initial velocity. It is initial velocity. It is initial velocity. Okay, the velocity at the starts of the particle, when the particle is at let's say starts its journey to motion. So I will say the particle, the initial velocity by which the particle has started. So like this the initial velocity will be. Okay, here v, what is v? V is nothing, it is the final velocity. It is the final velocity. After the application of force, you can say if the velocity changes, okay, the initial velocity changes to certain velocity, so that velocity is the final velocity by which the body is moving. Okay, that is the final velocity. What is a? A here is a acceleration. Here a is a acceleration. And what is t? T is particular time interval, or you can say it is the time. In this particular, this s is a new thing, and this is not a distance, this is a displacement. Always remember, this is a displacement, it is not a distance. Okay, students used to be confused in this particular second equation of motion. They consider s as a distance, but it is not a distance, it is a displacement. Okay, so these are basically the three equations of motion. As you can see, there is also one equation by which we can got the distance, displacement travel in nth time, that is equal to u plus a by 2n minus 1. This is our fourth equation of motion. You will just study these in your higher classes, but I have just explained you this also. This is the displacement travel in nth time. Okay, this is ascent. Okay, now what is u? U is initial velocity. What is v? V is the final velocity. A is the acceleration, t is the time, and as is the, it is not the distance, remember this, it is the displacement. Okay, this PPT has also taught us wrong, but I am there for you, don't worry. Okay, so this is basically a displacement, remember this. Okay, now how can we derive this equation of motion? Okay, first equation of motion, how we will derive? Consider a velocity time graph. Okay, we will just consider a velocity time graph. Okay, with a uniform motion. It is a uniform motion, so there will be a straight line. Okay, this is basically its initial velocity u, this is its final velocity v. Okay, and this particular time interval it is taken as t. Okay, remember this. Okay, now as you can see, this is the point A, this is point B, this is point D, this is point C, and this is point O. Okay, on y-axis I have taken velocity in meter per second, and this is time in second. This is the velocity time graph. Okay, so what is basically the initial velocity is u at A, you can see, and the final velocity is basically v, and it is at B. Okay, in time t it has changed. Okay, so basically perpendicular lines BC and BE are down from this point. So where is BC? BC is this line. Okay, and where is BE? where is BE? BE is this particular lines which I have drawn. Okay. Now similarly, and velocity x so that the initial velocity is OA and final velocity is BC. What is OA? OA is its initial velocity like this. This is the initial velocity and this will be its final velocity. Okay. And that is the time interval in which the velocity has changed. Okay. Okay. Now let us see further what is happening here. We can observe this one thing, that here BC, where is BC? BC is something like this. BC is equal to BD plus CD, BD plus DC, or you can write BD plus OA. And what is basically BC? BC is your B, okay, and what is OA? OA is your U, okay. By putting the value, what we get? We get B is equal to BD plus U, or here what we can get? We can get BD is equal to B minus U, okay. This what is V minus U? V minus U is basically change in velocity. This is basically change in velocity. Okay, and what is change in velocity? Change in velocity is something is equal to acceleration into time. Okay, what is acceleration? Acceleration is change in velocity per unit time. That is A equal to V minus U by T. So what is the value of V minus U? V minus is 80. So we can write this value at 80. So what we get? V minus U is equal to 80, or here what we get? V is equal to U plus 80. This is our first equation of motion. Okay, we have derived this equation of motion. Okay. Okay, so V is equal to U plus 80 is our first equation of motion. We have derived it. Okay, nice. Okay, now moving further to second equation of motion. Okay, so now deriving the second equation of motion. Okay, equation for position time relation is this. Basically, this is the displacement. Okay, it shows the position with respect to time. As you can see, there is a relation of displacement with time. Okay, okay. So now as you know, I have explained you in particular this thing, when you have a velocity time graph, let's say this is the velocity time graph. Okay, so basically area under this particular thing, area under a certain time, okay, gives us the distance traveled, gives us the, sorry, in terms of velocity we will say displacement travel. Okay, so we will just find out the area. So by finding the area, what we will get the displacement travel. Okay, so that is very simple actually. Okay, so let us move further, and what we will see there is a velocity time graph. Okay, also in order to find the distance traveled by the body between the points A and B, okay, is the area basically OABC. This is OABC. So basically I am highlighting this area, okay, for your better understanding. This basically area, this area you need to find, and in order to find this area we will apply some mathematical formulas. Okay, so this area, particular area, will give you the displacement traveled. Okay, so this particular area we need to find, and as you can see, this area is consist of two things. One, the area of triangle, plus this area of rectangle. Okay, so here by moving further, so finding area OABC. Okay, so this is area of rectangle, as I have explained you, OABC, plus this is area of triangle. Okay, so what is the area of rectangle? It is length into breadth. As you can see, what is the length here, let's say OA, and what is breadth? That is OC. So we have multiplied this, and plus what is the area of triangle? It is half into base into height. Base, what is base? Base is here AD, and height is its BD. Okay, so by putting these value, OA, you know, it is OC is equal to T, BD is equal to UV plus UT. Or by putting these values in this particular equation, what we get? We get S is equal to UT plus half AT square. Okay, what we get? We get S is equal to UT plus half AT square, and by this we derive this particular second equation of motion. Okay, that is very easy, na? Okay, now in order to derive the third equation of motion, what we are going to do, we are just taking the graph again. Okay, now let us have one question. Okay, let us have one question. Okay, so a racing car starts from rest. Something which starts from rest, always remember something which is at rest. So what is its velocity at that time? It is 0. Okay, so when the question says when it starts from rest, you must write u equal to 0. Its initial velocity will be 0. Okay, and has a uniform acceleration. Okay, these all are given things we have given. Okay, we are writing the given things. Acceleration is given at 4 meter per second square. Okay, so what distance it will cover in 10 seconds? So time has given basically 10 seconds. We know, right, that displacement is equal to UT plus half AT square. Okay, here initial velocity is 0. So S is, I am getting half into acceleration, I have 4, and what is T? T is time, it is 10 square is 100. So that will be your 2 and that will be your 200 meter. Okay, this is your displacement, or you can say that is basically the distance traveled in 10 seconds. That is very easy now. Okay, so like this, with the help of this equation, you can solve different types of numericals as I have explained you one on your PPT. Okay, now deriving the third equation of motion is also very simple. Okay, what is the third equation of motion? That is 2as, v square minus q square is equal to 2as. In this particular thing, we will just consider a velocity time graph. We have considered with the uniform acceleration. Okay, now basically what we are going to get, the distance traveled by the body between the points A and B is the area OABC. Now this is the area we want to calculate. First we have just divided this area into triangle and the rectangle, but this is, I can say this is one a trapezium. Okay, so we will find out the area of this trapezium, in particular this, in deriving this third equation of motion. So what is the area of trapezium? Trapezium area is nothing, it is the half into sum of parallel sides into height. Okay, so what is the area of basically trapezium OABC? It is the half into sum of parallel sides. Okay, remember this is the sum of parallel sides. The parallel side of trapezium are this OA, and this BC is the parallel sides, and this height OC. Okay, so this is the sum of parallel sides upon 2 into this height. You know what is OA? Okay, what is OA? OA is given U, BC is V, and OC is T. Okay, just put the value of V. What we get, S is equal to U plus V into T by 2. Okay, now further from velocity time relation, we know what we know. Acceleration is change in velocity upon time. Okay, so here we get time is equal to V minus U upon A. Okay, so this is basically T equal to V minus U. We put the value of this to T in this particular thing, and what we get U plus V, U minus V upon this 2 and this A, and this is equal to this S. Okay, so what we get, this is A plus B, this is A minus B, A plus B, A minus B is A square minus B square. So what we get A square minus B square, and this 2A will just transfer here. So what we get, 2AS. So V square minus U square is equal to 2AS we are getting. Okay, so this is all about the derivation of the equation of motion. The equation of motion is basically the beauty of the motion chapter. Okay, so basically I hope you have understood the lecture. Thank you so much for watching. Have a nice day.